let's get into some orbits. Johannes Kepler discovered in the 1600s that planets orbit in ellipses, not circles. Satellites, natural or human-made, also orbit Earth in elliptical patterns. Elliptical orbits remain fixed in space, and Earth then spins under a fixed satellite orbit. There are 6 different types of orbits that we're going to discuss here. Low Earth orbits, or LEO, polar orbits, medium Earth orbits, or MEOs, highly elliptical orbits, or HEOs, geostationary orbits, or GEOs, and a Molniya orbit, or MOLLE. I recommend pausing the video for a moment and taking a look at all of the different orbits in this image. Take a look at how they're laid out, where they're placed. LEO orbits are relatively close to the Earth, typically only several hundred kilometers, with no minimum altitude. LEO orbits are characterized by short orbital periods that are roughly 90 minutes in length. They have multiple revolutions per day, and swath areas, that's the area a satellite can see, is very limited. All staffed missions into space, with the exception of the lunar missions, have been LEOs. Many Earth-observing satellites have LEO orbits. These are the satellites designed to look back at Earth and observe it. What's in a name? A geostationary satellite stays in one spot with respect to the Earth. Geostationary. Achieved by placing a satellite at an altitude where orbital period is exactly equal to 1 day, or 24 hours. Its orbit is about 22,300 miles or so above Earth, and the inclination, that's the tilt of the orbital plane, is exactly 0 degrees. So this means it is directly out from that equator. There is only one altitude above Earth with an orbital period of 24 hours, and that is the geostationary belt. All geostationary orbits are in a ring around Earth that we call the geostationary belt. Space there is a finite resource, and it's getting crowded very quickly. I'm going to ask a quick question here. How can you tell what direction is south if you're lost in the middle of an urban United States area? There's no compass and you have no GPS receiver. Middle of a city, you're lost. How do you tell what direction is south? I recommend you look for a building or house with a TV satellite dish. Geostationary satellites only hover above the equator. Therefore, all northern hemisphere dishes communicate with geostationary satellites that are toward the south. Geostationary satellites for Russian communications pose severe challenges since a majority of its landmass is too far north for geostationary belt satellites to see it. The solution, then, was to create a type of orbit that they called a Molniya orbit, which is also called a MOLLE orbit. This kind of orbit allows long-term communications over northern Russian landmass. Molniya ground traces, that's an image on the right there of a ground trace, differ from most conventional ground traces. The image below clearly illustrates the satellite hang time over Russia. Remember this about orbits. If a satellite is moving toward the planet, it's speeding up. If it's moving away from the planet, it's slowing down. So when it is the furthest away from the planet it can be in its orbit, we find that it starts to go faster. And when it is the closest that it is to the orbit, we find that it starts to slow down. Okay, as it's moving toward the Earth, it speeds up. So looking at this ground trace, what we find is that as it swings through the southern hemisphere, it's going very quick relative to once it's crossed into the northern part of the hemisphere, it's starting to go slower until it reaches at its most furthest point out, and then all of a sudden it starts to speed up as it drops back in. That means it hangs over Russia and the northern hemisphere for a fairly long period of time. This is also seen in other types of orbits that position themselves in such a way. This one is specific, though, because this is what Russia created so that they can have this really long hang time. And notice the two different peaks in that ground trace and where those satellites are. Polar orbits are different. Polar orbits have a 90-degree inclination. So instead of being 0 degrees right over the equator, these are 90 degrees. These spin from top to bottom of the Earth. The satellite will eventually pass over all of Earth. The Earth spins underneath it. The satellite goes around it. Polar orbit satellites can gather information about the entire Earth because of this. As they go around and the Earth spins, they could eventually see or map out all of the Earth. Few orbits, and they've done that. This is great for weather satellites. Single satellites are often insufficient to perform the mission that they have on their own. So we employ groups of satellites in various orbits. They work together as what's referred to as a constellation to be able to accomplish their mission. A great example of this is our GPS system. Another more modern example of this would be Elon Musk's Starlink program. If you don't know what that is, I recommend you take a look at SpaceX's Starlink program. Okay, now that you know some of the basics, now that you've been introduced to what orbits are, use your new understanding of orbits to answer these two questions. If Norway wanted to obtain satellite imagery for all of its major urban areas, what type of orbit would be appropriate? Give it some thought. Could researchers at McMurdo Station in Antarctica use geostationary satellites for communications? Think about what the answers will be to those. I will not be sharing them with you in this video. However, I do have a series of 6 questions that I want to answer with you. 1. Planets orbit in circles, true or false? Take a moment. Hopefully you said false. They travel in ellipses. Name 3 types of orbits, number 2. All right. Hopefully you've named one of these. LEOs, polar, MEOs, HEOs, GEOs, or a Mali orbit. Did you get 3 of them? Number 3. Geostationary satellite can orbit around the moon. True or false? That's false. Geostationary orbits are not that far away. The moon is more around 240 to 250,000 miles away. Number 4. How long is the orbit period of a geostationary satellite? 24 hours. Number 5. Mali orbits are commonly used to view Russia. True. Number 6. A satellite in an equatorial orbit, that's an inclination that's equal to 0 degrees, will eventually pass over the entire Earth. True or false? False. All right, that's it for the introduction of orbits. Now on to more complicated stuff.